So this last topic that we're going to do, let me give you the title here. This is integrals with long division and completing the square. Which long division and completing the square are two things that you learned last year in pre-calc. And yes, you did learn them. It happened, in the first half of the year. And we're just going to incorporate those into an integral. So it's using skills from last year, which I know is tough because it's just so much to remember. So I'm going to review how to do those things first. This is, like I said with last time when we did the inverse trig integrals, this is so unlikely to come up. But if you read the standards for AP Calculus, it's in there. So I'm not going to skip it and not teach it to you, because if I do that, then they're going to throw one in there, But again, when you look at the bulk of what I've taught you this year and what calculus is and picking out the important things to worry about, this is not one of them. Again, I still want to cover it because it's part of the curriculum and it's fair game for the AP exam. They could put it on there. I'm just telling you it's not likely and it's not going to be a huge part of the test. So don't tune me out. I still want to teach it to you. But I guess what I'm saying is just don't stress about it. Okay. So first I'm going to just review how to do division. Actually, I wrote long division there. That's what they call it in the standards, but you could do synthetic division. So let me just do an example of how to divide. Before I even do a calculus example with an integral in it, let's just review how to divide. And I'm hoping that you guys all have a light bulb moment and go, oh yeah, I remember this. It's not hard, it's just been a year since you've done it. So this is in the polynomial unit that you would have done last year, which would have been in quarter 2. So whenever you're dividing by something like x minus 2, whatever number makes that 0 goes in a little box off to the side. So in this case, that would be 2. 2 is what would make this 0. So 2 goes in a little box over here. Is this jogging any memories? Or is this coming back to us? You're like, oh yeah, I remember this thing. Maybe a little, hopefully at all, somewhat. Okay. And then what you're going to do is take all the coefficients from the problem, but they have to go in descending order. So we have 1x to the 4th, and then we have -6 x to the 3rd. And then see how we're missing x squared? There's no x squareds there. We're going to put a 0 for that. We have no x squareds. And then we have 5x to the 1st, and then -4. And then what I always tell everybody to check to make sure that you didn't miss any. Oh, good, now we remember. To check to make sure you didn't miss any, just do a countdown. It sounds silly and goofy, but everybody ends up liking it. And it's to check you didn't miss anything. You should be able to count down from 4. So 4, 3, 2, 1, 0, blast off, okay? Just make sure that you have all the numbers there. But that always goes well because you're just thieving the numbers from the problem, basically. The only common mistake I see with this is people try to start the problem when there's nothing down here. And I'm like, what are you doing? You have to bring down the first number before you can start. So bring down the first number, and then it is multiply, add, multiply, add, multiply, add until you get to the end. So it's not difficult. You're just multiplying and adding. You just kind of have to stay organized. So multiply. So you're going to multiply by the number in the little box. So 2 times 1 is 2. And then you add that column. So -6 plus 2 would be -4. And then you just keep doing that until the end. So now we're going to multiply by the number in the box. So 2 times -4 would be -8. And then we're going to add that column. So 0 plus -8 is -8. And then do it again. So 2 times -8 is -16. And then if you add that column, that's going to be -11. And then one more time, 2 times -11 is -22. And if you add that column, you're going to get -26. And so when you go to write the answer, these are your new coefficients for your answer. you start with one less than what this original power was. So this was x to the fourth. We're going to start with x to the third. It's because you divided out, like you divided out an x, like x to the fourth, and then you divide out an x, you're left with x to the third. So it's going to be 1x to the third, and then it's going to go in descending order. So minus 4x squared minus 8x minus 11. So we did 3, 2, 1, 0. And then this is your remainder. So that just gets tacked on at the end, and you just leave it over the x minus 2. What you're basically saying is we're unable to divide out that x minus 2 from the negative 26, like that's left over. And so that is your answer. So we're just going to do that, but it's going to involve an integral as well. Yeah, the 2 comes from whatever makes this 0, whatever makes that denominator 0. So like if it was an x minus 7, you'd have a 7 there. If it was an x plus 1, you'd have a negative 1. So it's whatever makes that 0. No, you're good. That's why I did that. And we're gonna do this again in these next couple examples that I'm gonna do. It's gonna involve an integral as well. This 0 came from the fact that we have no x squareds. It has to go in order. So like we had 1x to the fourth, and then negative 6x to the third, and then we're missing the x squareds. Like there's no x squareds in there. And then 5x to the first, and then negative 4x to the nothing. This is like x to the 0 there. So it goes 4, 3, 2, 1, 0, blast off. So you always just want to do like the goofy little countdown. Okay, cool. All right, so, and I'm gonna do that again. There's just gonna actually be one extra step where we do an antiderivative. So it looks exactly like the problem we just did. All I did was put an integral symbol at the front and a dx at the end. Like that's it. Like you're gonna do exactly what we just did, but then take an antiderivative. So off to the side here, the number that's going to go in the little box would be 1. Again, it's whatever makes this denominator 0. So it'll be a 1 over here. And then we're going to just thief all the coefficients from the problem. So we have 1x to the third, negative 3x squared, 5x, and then negative 3. And so you should be able to count down from 3 for this one. So 3, 2, 1, 0, blast off. This one wasn't missing anything, so I didn't have to put any zeros in. It was all in order. So don't start trying to do the problem until you bring down the first number. That's the only thing that gets me is people will start trying to multiply. And I'm like, what are you multiplying by? There has to be a number there. So bring down the first number, and then it'll be multiply, add, until you get to the end. So 1 times 1 is 1. And then add the column, you're going to get negative 2. 1 times negative 2 is negative 2. It's always nice when this number is 1 because multiplying by 1 is real easy. All right, and then add the column, you're going to get 3. It's 5 plus negative 2, so that'll give you 3. And then 1 times 3 is 3, and then your remainder in this case is 0. What did the first one we did here with an integral to have a remainder of 0, just to make it a little bit easier. So you're going to put this back into the problem. And remember to start with 1 less of a power than you started with. Again, that's because you divided out an x. So if you have x to the third and you divide out an x, you're down to x squared. So it's going to start with 1 less. So it's going to be 1x squared minus 2x plus 3, and then dx. So like I said, it's just like we did up here, except one extra step where I'm going to actually do the antiderivative. So like this is the one step of calculus here. So this antiderivative would be 1/3 x cubed minus x squared plus 3x plus c. And so let's just try another one of those. And so I guess the question becomes, hey, Ms. Cole, how do you know when you should do this? Well, if it looks like you have, like a longer polynomial in the numerator and then something really easy to divide by in the denominator, basically if nothing else works, we have a lot of different methods of integration. So you kind of just need to think about all the tools in your toolbox and what the problem looks like and what's going to work. All right, so what will we put in the little box off to the side for this one? And good, it's going to be -3. Perfect. So whatever makes this 0. All right, and then we're going to take the coefficients from the problem. So that'll be 2, 4, and then a 0, and then -5. So we have 2x to the third, 4x to the second, no x to the first. It's like that's missing, and then -5x to the nothing. So you should be able to count down 3, 2, 1, 0, blast off. So bring down the first number, and we're going to multiply, add. So -3 times 2 would be -6. Add the column, and that will be -2. And then -3 times -2 is 6. Add the column, that'll be 6. And then -3 times 6 would be -18. Add the column, we're going to get -23. So this one does have a remainder. So when we go to put that back into the problem, it is going to be starting with 1 less than what we had. So it is going to be 2x squared minus 2x plus 6. And then the remainder just gets tacked on. It stays over what you had. We're saying we were not able to divide that out. Like this is what's left. And then so you have that one extra step, actually do the antiderivative. So this would be 1/3 x cubed, but there's a 2 there. So it will be 2/3 x cubed minus x squared plus 6x, and then minus. Now there's going to be a coefficient of 23, but pretend for a second it was just 1 over that. 1 over x is going to give you ln. The fact that there's a plus 3 in there is fine. If you were to do a u substitution, the derivative of 3 would be 0. It's just a constant, so it's going to go away. So it is going to be ln of x plus 3 and then plus c. Let me show you why that's okay. Because if you're like, wait, why are you allowed to do that with the plus 3 in there? Let me work that out off to the side here and just show you. So if you had this and did a u substitution, you let u equal that denominator, the derivative of that is just going to be dx. Derivative of x is just 1. And like I said, 3 is a constant. That's why it doesn't matter. It's going to just go away when you do that derivative. So when you go to substitute, you end up with 1 over u du, which is ln, and then you would plug this back in. But I don't want you to do all of that every single time. If you see an x plus 3 in the denominator, it's going to be ln x plus 3. Let me do one more like that. Not the whole division, because I think we did enough of those, but let me just do one more that is going to have an ln in that so that you can see it. Here, give me some numbers. We'll just make up a problem real quick. Type your favorite number in the chat, everybody. And I'll invent us a problem here. Only 2 of you have a favorite number? There we go. All right, we'll do that. So when you go to do this antiderivative, this first part, you would raise the power, it would be x to the fourth, you would put a 1/4 out front, but there's already a 6 there. So it'll be 6/4 x to the fourth minus, and then this one would be 4/3 x cubed, and then plus 7x. And then this one, 25 is going to be the coefficient. It's kind of like the 25 is just there. It's in the numerator. And it'll be ln. So 25 ln x minus 9, and then plus c.